Hi everyone, and welcome to our introductory video on how to use Eagle to analyze genome-wide association mapping data. But before we actually get into the fun stuff, there's just a couple of preliminary things we need to go through. So the first thing is, in order to use Eagle, you do need to have R installed in your system. So the good news is that R is free, it's fairly easy to install, and there's a couple of different options available on how you might like to install R onto your computer. So let me show you probably what's the most standard way, and I've actually got it loaded in my browser. So let's go together to the CRAN website. So if you type CRAN into Google, this is the website that it will take you to as its first hit. Not very spectacular, I know. Statisticians are very humble, aren't they? You look at this page, you think, this is a very humble looking page for a bit of software that's so impressive. But the nice thing is that everything associated with R can be found on this page, including how to install R for your system. So R is available on a OS Mac type system, for Linux, all the different versions of Linux, for Windows and so on. So that will get you up and running. It's probably not our preferred way of installing R. I'll tell you why. If you were to install R using the links available here, what it will do is it will install R for a single threaded machine. So R has always relied upon a bunch of math libraries, and those math libraries have been configured to only use a single thread for its computation. But we live in a day and age now where even the humble low-end PC and laptops come with quad-core CPUs that allow you to do multi-threaded computation. So let me show you an option. So again, I have it in my browser. If you type in Microsoft R Open into Google, then this is the page it will take you to. So the good folks at Microsoft have actually produced a version of R that looks exactly the same, performs exactly the same. Standard R uses all the same packages, so you can access whatever package you like using this version of R. But the big difference is that instead of coming with single-threaded math libraries, it comes with multi-threaded math libraries. Now, for those of you who are enthusiasts, you're probably familiar with the way of turning single-threaded versions of R into multi-threaded versions. It is a little bit technical, but we decided probably the easiest way of getting users to use a multi-threaded version of R is to actually get them to install Microsoft R Open, and this is what we have here. So if you land on this page, just go to the download link, and what you'll see, there it is. So what you see are all the different systems upon which you can install Microsoft R Open. It's the same as what you'd have for standard R. The only caveat with this is, we have installed Microsoft R Open on the most recent versions of all these systems, and there is a little bit of a caveat on how you do that. So what we've done is, on our Eagle webpage, we've given you some fairly detailed instructions on how you can install a multi-threaded version of R using Microsoft R Open on any system that you care to name. So if you're having troubles for a reason of installing Microsoft R Open, then I'd encourage you to go and visit our link. So the other thing that might be of use as a preamble to today is our Getting Started guide. So what we have here is really just a quick start guide that runs you through the basics of how you install Eagle once you have R up and running, and how you load in. It is geared towards those of you who are not familiar with R. So if you're a card-carrying R enthusiast, then you won't need to worry about this quick start guide. But it does go into how you get Eagle up and running, and it also talks about what the Eagle package looks like, some different ways of using Eagle, what the data needs to look like, and so on. Now I've returned to our home page, and I was in two minds of how best to demonstrate the use of Eagle through our GUI. But what I've decided on was the easiest route, and that is to do it through our demo page. So what we've done is, for those of you who might be undecided about whether Eagle's right for you, and really just want to trial it without going through the rigors of having to install R and then Eagle on top of that, what we've done is we have Eagle up and running on our test server. Now it won't give you the option of analysing your own data, but we do have some test data up on that server that at least gives you the experience of what Eagle's going to be like for you as a user when you start analysing your own data. So let's go to that demo page, and what we have here is the link. So here we have try Eagle. That will take you to our server. Before we do that, at the bottom here we just have the data files that are actually located on the server. So Eagle likes to have its data organized as 3 separate files. It likes to have a marker file that contains the marker genotypes. It likes to have its phenotypic data in a separate file that we're calling phenodemo.dat on our test server, and then the actual marker map that's contained in the third file, and we're calling that mapdemo.dat. Now there, in this case, they're all plain text files. There's a bit of a blurb about what's contained in each of them, so it's probably a good idea just to familiarise with that, and that way the video will make more sense to you. But let's assume, or I'm going to assume you've already done that. Let's go back and let's click on Try Eagle. So at this point, some of you are probably getting a little bit queasy in thinking, well, you know, if we're going to be using Eagle, then it looks like our data is going to be trundling off into the internet somewhere. Well, the answer is no. So we have written the GUI for Eagle to be in HTML code, and the easiest way of rendering HTML code is just to use a web browser. But all the computation and all your data is remaining local to your machine. Nothing is trundling off for you, so you don't need to get nervous that way. But here we have the landing page for Eagle, and on this first page I've just given you a bit of a schematic about the process you would follow in terms of analysing or performing a genome-wide association mapping analysis. So as I said before, Eagle likes to have its data split into 3 separate files, and again there's information on our Eagle website of exactly what goes into those files, and we even have a video on, you know, what those files look like and so on. So it's fairly detailed information sitting on our website. But just quickly here, we're going to have a genotypic file, a phenotypic file, and a map file. And it's really just a process of working ourselves along this navigation bar that sits at the top of every page. So the first thing we'll do together is we'll come along and actually read in the marker information or the genotypes. So we just go along and click on that, and here we are. So this page is pretty typical of what all the pages are going to look like when we're reading in information. So you have this orange bar that sits at the top of the page, and if I hover over this, what it will do is it brings a pop-up box for you that gives you detailed information. So I don't expect, probably not many of you will ever read this information, but I thought it's useful to have it there. If you're bored or looking for something to do, then this gives you a pretty detailed view of the type. Sorry, let me back up and get me too excited. This gives you pretty detailed information on what's actually going on this page. So let's just work our way through these steps, and there's 4 of them. So the first thing we'll do is there 4? Yes, there's 4. So what we'll do is choose the file type, and as I said before, Eagle gives you the choice of 2 different file types for the mark information. You can even have a p-link ped file, and that's just a very standard format, and we just follow just the standard way of doing that. Or you can have a plain text file that's a little bit more flexible in terms of what you can do. So the information that's sitting on our test server is a plain text file. So we click on that, and what happens is the page changes dynamically based upon your decisions. So now, if you are using a plain text file, we have given you the freedom for you to call your SNP genotypes whatever you like. So, you know, if you're very creative, you might want to call them Tom, Dick and Harry, then that's up to you. But you do need to tell Eagle what those creative genotypes correspond to in terms of the underlying SNP genotypes. So for the marker data that we have sitting on the server, we haven't been very creative. We've just called them 0, 1s and 2s, where the 0 corresponds to AA, the 1 corresponds to the heterozygote, and the 2 corresponds to the alternative homozygote. We don't have any missing data, so we don't need to put anything in here, but Eagle will handle missing marking information, but in this, as I said, this case, we don't have any missing information. So, second step. Second step is to specify the amount of memory you've got available on your system. Now, in the case that we're looking at here, it's such a small data set that we don't need anywhere near 8 gigabytes to analyze the data. But so I think it's just a good habit for you to get into setting this to be the most amount of memory you have available on your system. Because when you do start analyzing these larger data sets, then the more memory you have at your disposal, obviously the faster the analyses are going to be. So the good news is that Eagle will handle data sets larger than the memory capacity of your machine. The cost of that is time. So what we do is when you have, say, a huge marker file that has, I don't know, gazillions of genotypes, and whatever reason you're running on a fairly small system, we will break that up into sensible blocks and then analyze each block using Eagle. But it comes at a cost, and the cost is time. So it's a good idea just to get the practice of actually putting in the most amount of memory as you can in this option here. And you just can do that either by typing in directly or by using the arrow bars. Okay, so now we're in a position where we come along and actually select the marker file. You've got two ways of doing this. You can click on this select file option, and what that will do is it will take you to our file browser, or you can type in the name directly. And I'll talk a little bit about when you might want to do this. So you're probably wondering, why would I ever want to type in the name directly if I can actually just use a graphical interface to look for the files? So by clicking on select file, what you'll see is it takes you to this file browser, which is from Shiny Files. So it's actually a package that sits within the R environment that allows you to view files. There is a caveat that comes along with that, and that is when you use something like Shiny Files to view files, when you use Shiny Files to view files, then you're a little bit restricted in how far back in the directory you can go. So it's designed for systems that are working on a server where you may want to limit access to a user on the whole directory structure. So we've been using this with a little bit of fear and trepidation. We're not quite sure how it's going to go, but we'll see. Well, send us some comments if it's not working for you. What we've done is we've had to decide on a default starting location. So if you're a user and you're looking at this and you can't see your files, and you can't even see the directories in which you need to navigate through to get to your files, then our backup option is to come along and for you to type in the full path name here. So there is a backup option, but ideally we're hoping that for most users they'll just be able to see what they need in this select file option. And in this case, in terms of the server, what I want to do is I want to click on genodemo.dat because that contains the mark information. Once I've highlighted it, I just need to select it, and now I'm in a position where I can just upload the file. And what will happen is once I click on this, there'll be a little animation that will come and go very quickly because the files are very small, but it appears in the lower right hand corner of the page, so look out for that once I click the button, and then you'll have some summary information that appears in this right hand panel. So let's do that. And there it is. Okay, it happened all very quickly because it's such a small file. But again, I think it's good practice just to have a quick browse through this to make sure things are working the way you think they should. So as I said before, the marker file contains 1s, 0s and 2s, and you can see the first 5 rows. So it gives you a little bit of a sample of what's being read in. So it's a good idea just to make sure that's corresponding to what you think should be read in. And also there's some summary information that sits down here in terms of the number of individuals and also the number of loci that you have. And again, it's just good practice to make sure that they're lining up with what you know should be the truth. Okay, so let's do read marker phenotypes. Again, hopefully this is just really simple. You know what I mean? We tried. The ultimate compliment you can pay to me is, you get to the end of this video and think, really, do I need to sit through that video to use this? That would be just an amazing outcome from us, because we've tried to design this in a way that's just so obvious and intuitive and easy for people to do. So in this page here, again, we have this hover bar where it contains information associated with the missing page if you're bored or having your cup of coffee, have a read through of that. But then we just work our way through this form. So the first thing, like I forgot to say this, but in terms of the mark information, you can't have column headings, and that's by design. But in terms of the phenotypic data, you can. So it makes more sense to have column headings in the phenotypic file because you need to know what traits are and covariates and all sorts of stuff. So in this file, it's up to you, but for the data that we've provided on our server, the first row actually contains a column heading. So I want this option to be left as yes. And for the phenotypic data, we give you the option of whether you'd like to have your file space or comma separated. For the marker file, everything has to be space separated, but for the phenotypic file, it can be space or comma separated. And what we have is we have a space separated file, so we can just leave this under the default option of no. Again, we don't have any missing information because it's just toy data, and we come along and select our file. So we're going to use the file browser to do that. We'll click on Pheno Data. There we go. Click Select. And the name or the path, the full path will appear in this dialog box. And then we're in a position to upload the file. And again, things will happen so quickly, but there will be a little animation bar that appears at the bottom. So the thing with animation bars, you might think, oh, that's just a little bit of bling. Actually, it's not. So when you have very, very large marker files especially, it does take some time to load those files up. And what we found was, once you do that, nothing appeared to happen. And we kind of left the user in limbo in that, has it crashed or is it doing something or what's going on? So the animation bar actually makes a lot more sense when the system takes a bit of time to load the information up and so on. But here we go, very quick, you barely see it. And it gives you, again, summary information that's just as good practice, just to have a flick through and make sure things are being coded the way you think they should be, or being read in the way you think they should be. So here's the last file to read in. It's the map file, and it's optional. Eagle doesn't require a map in which to do its analysis, but obviously when it comes to interpreting the results, it just makes so much more sense if you have a map file from which to interpret your results. So if you don't supply a map file, Eagle will just generate a generic file for you. But obviously I can't imagine this day and age where you don't have a map file from which to go from. So let's do that. We'll read in this map file, and in our map file it is a space separated file, and the first row contains the column headings. So we can just leave these as yes for the first step. The second step is space separated, so again we want no, it's not comma separated. We're going to select our file. It's going to be the map demo.dat file. Select, upload the file, and then you have the summary information appear on the right. Now we're in a position where we can actually come along and have some fun. We can actually analyze this data. So what we want to do is come along and click Analyze. And here we have it. So Eagle obviously doesn't know which is your trait and which are your covariates or features or fixed effects. So you have to tell Eagle that. So in the first step, you just say which is the trait. And we'll be, well, look, I wasn't very creative in the naming of the traits, but here's trait 1. Which is the first trait. And you can have as many traits in this file as you want. For example, if you've got 10 traits, you don't need 10 separate phenotypic files. So you can have all the phenotypic information can be sitting in a single file. And that's true for the fixed effects as well. Whatever fixed effects you have, whether you use them or not, can all be sitting in that single file. Okay, so we have the trait. Let's just pick, I don't know, in terms of fixed effects, PC1 and PC2, which is corresponds to principal component 1 and principal component 2, and what you see is this additive model starting to be built up here. Third step, specify the number of CPU. If you have a system that has multiple CPU and you've got R configured to use those multiple CPU, then by all means you should change this to be the number of threads, number of threads you have available to you in which to do the computation. On the test server, we only have a single thread, so we'll leave this as 1, but definitely a good practice. You'll get the most out of Eagle if you set this to be the maximum number of CPU available on your system. So now we're actually in a position where we actually leave additional options. We'll just leave that for the time being. It just has a few things that, probably more for my benefit than anything else, that it's possible, like Eagle is an iterative process. It builds the model up iteratively. So we do have a safeguard in there that if it, for some reason, it has, it runs away in terms of analysis, then there's a way of breaking out of that loop. Being honest, we've never ever reached that maximum. We've never needed that, but it's in there just as a good coding practice. So you can set, under additional options, the number of maximum iterations, and there's some other options in there as well, but we'll leave that. So step 5, let's come along and actually do the analysis. And it happens so quickly, it's not, not particularly exciting, but you have a bunch of stuff that comes on the right-hand side, and what we have here are the results. So let me put this in the context. When you do single locus analyses, you end up with, something that looks like a Manhattan plot. From there, you have to have your threshold. So you have to decide, if anything sits above that threshold, then yes, this is truth. Anything that sits below that threshold, then it's not. You have to worry about how close the peaks are to each other. In Eagle, we don't have any of that. There's no thresholds to set. There's no peaks to worry about. We've done away with all of that through the methodology that we have implemented within Eagle. All we do is we give you what matters most to you, and that is you want to know which positions on the genome are closest to the genes that influence the trait. That's the ultimate question that you should be trying to answer with any type of analysis. So what we've done, what Eagle does, it gives you those SNPs that are closest to those genes, and it also tells you the number of regions that we have. Like even getting a number of regions can be tough with those single locus analyses. So Eagle solves a number of problems simultaneously. So from this analysis, we're able to say, yes, there are actually 2 regions on 2 separate chromosomes that contain genes that are influencing the trait, where the first region is at map position 25 blah blah blah, and the second region is on chromosome 19 at map position 35, and you can read as well as I can. Okay, now the output from this is not very pretty, we realise that, so what we want to do is we want to actually make it look a little bit more appealing. So once you've run the analyses, the last thing you need to do is actually go to findings. And here it is. So it just gives it to you in a slightly more palatable form. But not only that, is if you click on this little histogram thing, we do some initial analyses or summary information. And what we have here is a further 2 tables. So the first table gives you the marker trait associations. So these are the things that matter most. But in terms of size and significance, that may also be of interest to you. So we'll estimate the additive effect and also the significance of that effect in that final linear mix model that we come up through Eagle. But also we talk about the amount of variance explained by those markers. So for those of you who are very familiar with analysing real data and so on, you'll see that these are very large effects. So these are not real life effects, but it's just a toy example to get things to work for you. But here you have it. So there's your first analyses using Eagle. So just one last thing is, when you're using Eagle, say you're stuck, say you're having problems, and where can you go, what can you do? So the first thing you can do is click on a help link, and really what it'll do is it'll take you back to our Eagle website, because there's a whole lot of information contained on this website. So what we've done is, there's information, there's a quick start guide, there's information on how for you to install multi-threaded R on your system. There's a number of different videos we've had besides this one. So there's a video on, what is Eagle, what's it all about. Here's a different to what's already sitting in the main domain. How should you organize your data, all those sort of things. And also what sort of views, answer to some frequently asked questions. So we've had a guest, since Eagle is new, we've had to guess at what these are. But we've designed a page that contains a whole lot of questions that we thought you might have when first using Eagle. And all you need to do is just click on each of the arrows, and it will give you the answer to each of those questions. So we're hoping that for the bulk of the questions, the answers will be contained here. But in the worst case scenario, if that's not the case, then what you can do is you can actually email us. So we have set up we've set up an email account for you for you to email us with any questions. So as I say, we are a small team. It might take us a little bit of time to get back to you, but we will do our best to answer your questions, and especially if you find bugs. So, we've done our best to try and test all different parts of Eagle and so on, but it does have many working parts, and some parts have been tested with varying degrees of rigidness. I don't know if that's a word, but anyway. But yeah, you get the idea. If there's bugs, please email us and we will set things right.